Okay. Yeah, very interesting that I have ChatGPT open. But yeah. Okay, so this one. This one. Is it this one? Wait, sorry guys. Trying to see which one is which one. Yeah, this is two. Okay. A little bit of complications. Alrighty, so today we're gonna learn basically two new things. As I said, MOSFETs and diodes, how to use them, how impactful they can be in our circuits. But before to get to them, we did some tasks yesterday, so we're gonna go over them, solve them. Anybody has any question before we get started, like from the beginning, last two lectures? No questions? Okay. So here's a sign-in sheet for whoever has not done it yet. Please do it. And then, yeah, I'll go. Okay, so for the first one, we can use basically two ways that I use at least, right? We can combine the resistors, right? Find the total current. Then, because we know the voltage at this node is basically the same thing, right? We can just say, okay, we gonna calculate what is the voltage drop after the 5 ohm, right? And we can say that. Or instead of just calculating the current, right, we can use the voltage divider after combining these two like resistors, and we would just save time for ourselves and like less calculations. Any questions? Anybody has any question about this? One question, two question, three questions, nothing? Okay, also send your text messages to my, what is it called? The one that it has a camera, not the one that is sharing, okay? Because I can really check the chat that way. But yeah. Okay, so we will move forward. The second question that we had was the equivalent capacitance of the circuit, the total, basically the circuit, right? So again, if they are in series, we use, C1 times C2 over C1 plus C2, right? Basically, like the resistors being parallel. And if they are in parallel, we add them together for capacitors. Any questions about that? Everyone's okay? Okay. And then we basically move forward from the innermost section of the circuit, which is here on the rightmost. We start, so these two are in series. We add them the way that they should be added, 2 times 10 over 2 plus 10, 20 over 12 microfarads. And then we're gonna have these two in parallel. We're gonna add them. We're gonna end up with 80 over 12. And then they're gonna be in series. So we do that again in parallel and in series, and we're gonna end up with 0.81 microfarads. Anybody has any questions about this, or do you want me to solve it or anything like that? Just put in the chat. Don't hesitate. Ask me any questions you have. Because I saw a lot of people in your answers, you had ohms here. So, and I think it was my mistake that I didn't talk about that what is it called? We measure capacitance in farads, right? So when we talk about total capacitance of a circuit, we're actually talking about farads. Any questions? Right? Everything's good? Everyone's okay? Okay, so we'll move forward. So we will get to the fun part. So how does the switch work? So I actually explained this a little bit wrong yesterday, right? So the orientation that you should have it was right, but the way that it would connect was different. So the left one and the right one, they would connect when you press it. So yeah, I'm sorry guys, and hopefully I would have figured it out first before, but yeah, I just kind of said it wrong, so I'm so sorry. Any questions about that? I would explain how the truth table works, yeah. And could I post the slides to the web? Yes. Can one of the mentors please do that? Post the slide to the web. Thank you.
I got you.
And then can you explain left and right with the picture? Yes. Next one is the picture, I think. Yeah, here. Okay, but before that, I just want to go over open vs short circuit, and then I explain the switch again. I'm sorry. So anybody can explain what is the difference between open and short circuit? Just open your mic and just say it.
Open circuit is like something's stopping the current from flowing, so normally it's like wires disconnected. And then closed circuit is like your circuit's entirely enclosed and the current can flow um continuously.
Yeah, what is the short circuit that we have here? So, we always say open circuit or short circuit. What does a short circuit mean if we know what is open circuit? Anybody knows?
I think a short is when you have like something's in parallel and one is like just a wire, so you short it because all the current wants to go through the wire, which has low resistance compared to like other thing that has a lot of resistance.
Right, that's totally right. Um, yeah, short is when there's no load or there's like really low resistance, right? So so tell me guys, which one is bad for us? Short circuit or open circuit? Which one is going to damage our circuit? Why a short circuit would damage our circuit?
You could overheat something.
Yeah, that can be one. What is the other one? What is a bigger reason?
High current.
Yeah, yeah, exactly. The too much current going through the sensitive components. Yeah. So at first, we really said we need resistors to control our current because current is the one that's going to damage us, right? That one is the one that we don't want it to be too much, even though we need it, right? So in any circuits that you make, you don't want to make it short, but you rather want to make it open, or you want to make a like a what is it called, really lower resistance kind of path sometimes that is controlled, right? So if you short your circuit by mistake, you might catch it on fire, right? This happened actually one time to me. I was using batteries, like mentors, they remember. And then basically I wasn't doing it by mistake. It was an accident, but the two terminal of a battery, they basically touched and it started catching on fire. So this is something that you need to be really careful about. And if you're using really high, like high discharge rate batteries, you don't want it to happen. You don't want to short your circuit. So what is the thing that people use or like engineering use to prevent a short circuit? What is the tool they have?
A fuse
Right. What does a fuse do?
just cuts off this current at a certain
Hmm?
racked off like a switch.
Kinda, yeah. What happens? Yeah, it breaks the circuit, right? So typically the fuses, the way they work is that they have some sort of material, like let's say, they made of like some sort of a metal that they still conduct electricity, right? But then when the current goes higher than what is the rating for it, they either burn or there's like some sort of a mechanical component for a higher, like let's say transformers that they provide so much power and current, right? So there's like some sort of mechanical thing that would break the circuit and never let the current go through, right? Because sometimes even if you're dealing with a high voltage, right, there is still a chance to you conduct current. Does anybody know how? Even if there's no wire, what is the way that they can conduct current? Right, through air, because it's gonna, what does it call, kind of arc, right? So if you have really high voltage, right, and they're kind of close, like a capacitor, let's say, the high voltage is really low, so it can actually kind of make the oxygen to be ionized, right? And it will just conduct current. And this way, it can also damage your circuit. So sometimes later on in industry or like in your classes, you'll see that it's really important to think of a fuse that would actually work, not to just be there that doesn't work, right? So sometimes you need some sort of mechanical aspect for your fuse also to kind of push away or pull away the higher voltage side. So you never conduct current anymore till your device is fixed, right? Because you want to protect your circuit. Any questions? Nobody has any questions? Okay, so now that we know what is open and short circuit, can someone tell me what was the way that we could kind of control our circuit for our task? Anybody knows what was the tricky way that we were like using to kind of light up our LEDs the way we want it, right? Or opening the circuit, right? To kind of not let it to happen, have any voltage, right? Both way works. What was the reason that we could short our circuit, like in our task? Like it was kind of possible for us. Oh, I don't mean it like that. I mean, what was the reason that we didn't catch on, like our wire didn't catch on fire when we shorted? What could have been? I mean, a 5 volt can be also dangerous.
Because we have a resistor in the circuit to protect it.
Yeah, that's kind of why one of the. So one of the things, we have two things, right? Our power supply is not going to supply too much current anyways, right? So it's not a 2 amps, let's say, power supply that can actually provide that 2 amps, right, to your circuit, right? So the second thing, as other people said, there is a resistor, right? And each resistor has a rating, a wattage rating, right? So they can handle up to 1 watt, let's say, I don't know, 0.5 watt, right? So you can do the equation we said, right? So if you have 0.2 milliamps, let's say, and 220, I think the formula is like IR squared. So you can kind of calculate and see which one, if you see on a range of power rating, right? So anytime that you kind of make a circuit, also think about the power rating for your components, right? You don't want to burn them, right? There's a chance that you put, let's say 5 volts, but your battery can discharge up to 2 amps, right? So then your resistor is going to get really hot and it's going to stop burning, right? Or maybe your wires are not even capable of handling that much of current. So your wires are going to actually start smoking, right? So this is a really important topic in basically any electrical engineering, any power electronics or anything. Any questions? All good? Okay. So yeah, I made a mistake yesterday. I said these two are going to get connected, but actually these two lines are connected together, right? So when you press it, this is going to get connected to this, and this is going to get connected to this, right? Any questions about this?
Could you say that again?
Yes, yes. All four is connected when you press it again. Press them. So, imagine how do I kind of explain this? So we know on a breadboard these four lines are not connected, right? So when we put it in the middle, these four are not connected at all. I mean, these are connected, right? This is connected to this still through the switch, right? So you're kind of giving, imagine here there's a wire, okay, like this red wire is here, right? But then in order to give power to this rail, right, we need to connect the wire again to have the same amount of voltage here, right? But this is what the switch is going to do for us. So when we press it, this is going to get connected, right? So this line, the red line is going to get connected to this. So there's going to be a four kind of connection throughout the thing. So it's going to become one node basically.
So Sina, quick question. So the two red lines are already connected when you put it there, right?
Yes, exactly. Yeah.
And then once you click the switch,
They're
it
going to
connects.
get connected too. Yeah. It's
Okay.
like, you know, it's like you putting a wire here,
Okay.
right?
Okay.
So they're going to connect to each other. Any questions? Yeah. I'm sorry. I made a mistake yesterday and, you know, in explaining. So I'm so sorry. Yeah. I think I just went over too fast. Yeah, no problem. Okay. So this is our basically NOT gate, right? So again, because these two, what does it call? Over here, right? We can see that circuit is going to be completed this way, right? Without pressing it, right? But when we press it, the circuit is going to be connected, but this is a path of lower resistance, right? So the current instead is not going to go through this, but it's going to go through this, right? That's why when you press this, this is going to go off. Any questions? Were you guys able to figure this out?
Yeah, but I didn't understand what's going on. Now I just got it.
Right? Okay, yeah. So the current always, oh, I think we talked about it yesterday, that current always wants to go through the path of less resistance, right? So the trick here is to make a path of less resistance, right? So you want them to be connected all the time, but when you press something, it's a path of less resistance, right? So it would go through. The resistor here is basically acts as a protector, right? But maybe we could just have a resistor here between, like, you know, these two legs also, right? Then, you know, we could just make this a wire type of thing. So we just short it right away. So then it would 100% work, right? But there was a chance of us, you know, kind of, if we had a higher, you know, wattage battery or a higher discharge, we would just make our circuit bare, right? We would just burn our switch. But then later on, we're going to see what it can actually replace this switch, which is really more useful, right? And can actually automate our stuff, right? So it's really important. So any question about the NOT gate? Why it happens, why it works, what is the thinking behind it? Yeah. All good? Okay. So this one is the AND gate, right? So these, we need to make a connection when they're both pressed, right? So we can see the power, right, can only come from this side, and our circuit is going to be only be completed when we press here too, right? So this is the path that it has to take to go, right? So if I press this, this is still not connected, right? So if I press this, this is still not connected, right? But when I press both, they're both gonna get connected and I'm gonna have a complete circuit, right? So the trick here, what is it? Is it a shorting the circuit or is it opening the circuit? Which one is it?
Opening circuit?
Right, we're gonna keep the circuit open as much as we can, right? Yeah. So this is kind of our AND gate. Depends on, you know, how we define what is our 1 or 0, right? Yeah, basically, yeah. Is it just one series loop with two switches? Yes, exactly. Yeah, because, like, you know, they're all in series, right? But as long as they both need to be connected, they need to be both pressed to kind of complete the circuit, right? Any questions about this? All right, so this is our NOT gate. So NOT gate is basically gonna use the, how do I say it? Kind of the same way of thinking as the AND gate, but we want to kind of open our circuit at this point.
Is this not or the NAND gate?
Oh, no, I mean, no, I'm sorry, NAND gate. Yeah, sorry. Yeah, I meant the NAND gate. Yeah,
Right.
right. I kind of have it here too, so I can show it, I think. Yes, I do have it here. So this is a little bit harder thing to kind of see, I believe. So let me just wire up the circuit I'm gonna show. Yeah. Anybody has any questions about the NOT gate? What is the trick we're gonna use?
Do you use four switches or just two?
No, two. I'm just getting the power from the top circuit here.
Okay, okay, that
Yeah,
Okay.
yeah. Okay, let me. I have a big LED here, so I'm gonna use it. Okay. So, can you guys see my camera? Right? So if I press one, doesn't turn off. If I press the other one, doesn't turn off. I have to press both, turned off, right? So,
Close this
yes.
light so we can see your, like, cause it's like a small for me, like, your,
Okay, yeah, I'm sorry. I'll fix this right now.
thank you.
Yeah. Recording, no background, no. Okay. Can you guys see me better?
Yeah,
Yeah, okay. So if you pay attention, if I press this, right, it doesn't turn off. Press it, doesn't turn off. If I press both, it turns off, right? So the trick that we're basically using is that we have a complete circuit all the time, right? But the only way that the circuits are gonna be incomplete is to basically open them, right? So when we press both of the buttons, right, it's gonna open our switches. Actually, it's gonna short in one side. It's gonna short one side, and it's gonna open one side, I think. Yeah. Yep. It's gonna basically short it. Yeah. So any questions? A better solution is to kind of have a grounding on the right side too. So you can ground it and you can see the short better. I believe. But yeah. Or maybe I'm lucky and just made it happen. So I don't know. Any questions? Does anybody have any questions about this? All good. Everyone's okay. Yeah. Did you guys like the, what is it called, the task? Just say yes or no. Just be honest. Just say put a no if you didn't.
yeah, it was fun.
Yeah. Okay. Okay, that's good. I think today is gonna be a little bit more challenging too, but it's gonna be only two. Okay, so I hope you guys enjoyed that too. Okay, so now we are gonna get to diodes basically. Anybody knows what is diode? Anybody can open their microphone and start talking about diodes, semiconductors, our E friends, E students, mechanical engineering students. How many of you guys have ever used a diode in a circuit? Just, if you have used, just say yes. Right. Okay, so the ones who said yes, what did you use? Right, LED, right? LED is one diode, right? You know? Yeah. Okay, so diodes are basically semiconductors, right? If you're E, you would take EC2 first, and that one is basically physics of semiconductors, and semiconductor physics is gonna be really interesting, right? It is really just in depth talking about semiconductors, but if I just want to talk about them really quick, just give you guys some information, is that we have electrons and holes, right? So holes carry positive charge, electrons carry negative charge, right? And the trick that they use in semiconductor, we call it is doping. Anybody knows what is doping? Doping a semiconductor.
I think it's when you use a particular element on a semiconductor to provide it with either more or less electrons to get a certain property out of it.
Right, putting impurities or like, just like putting some other type of material on top of your semiconductor, let's say silicon, right? To either introduce more electrons, right? Or introduce more holes, right? I want you guys to think about holes as basically empty spots for electrons, right? So in chemistry, if you had only one atom, right? If you pop the energy, like if you put energy into it, the electron would pop, right? So the empty spot is basically the hole now, right? The electron just popped out of it, right? But in actual semiconductor, we have a whole material, let's say like, I don't know, 10 angstrom together, 10 angstrom meter squared kind of together, right? So then it's not only one atom, it's a connection of them, right? So the bottom one, what we call it, is going to be the holes, right? And the top rail that you're going to have is going to be your electrons that are going to get popped up. So if I want to draw, I can kind of show this. Give me a second. Give me a second, guys. Okay. So, yeah, over here. Sorry. It's on my board. Okay. So what do we have now that we have a piece of semiconductor? We're going to have a valence band and a conduction band, right? So in valence band, we typically have a lot of electrons, right? So imagine we have electrons, right? But then if I emit some energy here, right, or warm up my device or something. Wait, Ryan, I think your mic is open. Yeah. Oh, if we, put energy or something into it, right? One of these electrons might, right? There's not 100% chance. Later on, you're going to learn there's a possibility of them jumping, right? But they're going to move to the conduction band, right? So if an electron comes here, the empty spot is a hole, right? That has a positive charge, right? So then to just keep it short and not like, just be informative, the p-n junction is that. So in semiconductor, p is the holes, and then n's are the electrons. Any questions about this? Any questions? Okay. Then, basically in a diode, we have a p-n junction. So we have a p side that has a lot of holes. We have an n side that has a lot of electrons, right? And then we have two types of currents again. We have a diffusion and drift current, right? And the way, inside the semiconductor, I don't really want to get deep into it because it's really hard topic. But then basically when you apply voltage across either P or N, right? One way the current is going to go through and one way is not going to go through, right? So then we're going to have a forward bias and reverse bias, right? So the forward bias is when you have it in the right format. That means like, your positive side is on the right side. So then you're going to have a conduction or a current going through. And when you have a reverse bias, your diode is going to basically stay against the current going through, right? So it's in a reverse bias, right? And a threshold voltage is basically you need that amount of voltage to open or let the current go through the diode. Otherwise, it's not gonna, even if it's in a forward bias, it's not gonna conduct electricity. Any questions? Everyone's good? Okay. So why do we use diodes basically? Does anybody know? Anybody know why we use diodes? Just open your
Make
mind.
sure your circuit behaves in a certain way that we want it to.
Right, that's one of them. What is the other reasons? Yeah, so diodes are basically like a brake, right? So you kind of want to prevent something happening in your circuit, right? So they would work one way, but not the other way, right? So one of the best examples that a diode would work is when you have an inductive load. I didn't really go over inductive, like what is it called, inductors or like any inductive load, but basically an inductive load, if I want to just keep it simple, and if I'm right, is that when you have a current that changes through time, right? You're gonna have some sort of a noise. So we can use a diode in a reverse bias against inductor to kind of cancel the noise because any inductor has a damping ratio. So if you're really interested, you can actually kind of simulate it with LT spice. And you're gonna see how it's gonna save your kind of circuit. Okay. But then yeah, so also one of the best usage of diodes is in your AC to DC converters, right? So what we call rectification, right? So you're gonna have four diodes that are gonna point toward each other, and this will just rectify your circuit, and then later you can have a capacitor, right, to cut off that frequency, and you're gonna have a DC voltage now, right? And in logic gates, they use in one of the example for logic gates is drive inverters, right? When you have a really high switching, you don't want any inductive load or any current going backwards. So you want to kind of protect that as well. Okay, any questions? All right. So how do we use the diode? Is that the current will only go through one way again. So in the diode that you have in your kit, if you go get it, right? The black side to the silver side is the one that is going to conduct current, right? It's like a LED. So if you have a LED, imagine, right? The black side is your like a long leg, and the silver side is your short leg. So that's how it's going to conduct electricity. Any questions? All right, so how we can use a diode is basically just in a circuit, right? You can see if the black side is this way toward the positive, it's going to conduct current. And if it's the other side, it's not going to do it, right? So yeah. Okay, anybody knows about MOSFETs or transistors?
They're like signals that opens the door when it receives a signal, closes it.
Yeah, right. Has anybody used MOSFET before? Just say yes or no if you have ever used a MOSFET.
I haven't, no.
No. Okay, so the good thing is that you're gonna actually use it today, basically. So, you're gonna kind of learn how to use it. I think it's gonna be the fun part of it, right? Yeah, because I kind of tried to have the circuits more interactive and kind of more hands-on than just theoretical. I think you can always go learn the theories all the time. There's a lot of videos outside on YouTube that you can just go learn how to solve a problem. But when you do something practical, it actually helps you more with solving a problem, right? Because it's really different. You still have to do practical things. And I personally am more of the practical guy. I like to just practice things, just put them together. It makes more sense to me. So yeah, the ones who have used the MOSFET, what did you use for?
I
Can you
used
just open,
a NPN transistor to act as a switch.
right? What was your application I used it? What were you using it for?
I don't really have an application. I was just trying to figure out how to use it.
Oh, okay. Yeah. So a MOSFET is something like that has three terminals, right? So three legs, right, left, middle, and right. What we call them is a gate, drain, and source, right? So the first pin from the left is basically your gate. The middle one is a drain, and the third one is a source, right? And again, we have an N-channel MOSFET or a P-channel MOSFET, right? Again, electrons and holes, right? So the P-channel MOSFET, that means the two side of your MOSFET, if you go and actually look at the page, like the pictures, there's two heavily uh P doped type of thing, and then there's the middle one. Your gate is N MOSFET, right? Kind of N channel, and then the other one N channel, you have two heavily doped electron, and then your gate is basically P sided. Any questions about that? So that kind of explains why we need a positive voltage for a N-channel MOSFET, right, to open it, and why we need a negative voltage to open a P-channel MOSFET, right? Does anybody know why people use MOSFETs? Any idea?
To control, for example, a LiDAR, maybe it's laser or something.
Yeah, logic is good. Yeah, that one too. So anybody know what is the difference between a MOSFET and a BJT or IGBT? Yeah, anybody knows what is a BJT? No? IGBT? No? Okay. So they are kind of the same semiconductor devices, right? But they each have different, what does it call, properties, right? BJT is an older kind of technology, and then IGBTs are sometimes used in some application that MOSFETs are used, but MOSFETs are the most used one in the industry. So it's really good that, even after this workshop, we go study them, learn how they work, and maybe do some projects with them, right? When you learn how to use your Raspberry Pi, you can order some MOSFETs and use them. We only had one for you guys in the kit, so we're gonna try to use that. And then yeah, so if you have any, I don't know, interview or anything, this is a good one to kind of know because it's really applicable to in a lot of applications, right? From drive inverters to some power issues to basically your phones, your computers, they all use MOSFETs, transistors, right? They all use for logic gates, right? So you send a signal, it opens up, and you send the other signal and it turns off. Any questions? So, basically, how does a MOSFET works? Let me show to you guys. I have a picture, I think, in the next slide. Yeah, here. So, if you hold your MOSFET this way, basically, the kind of the big side toward you, the way that the picture is showing, the left one is going to be your gate, the middle one is your drain, and your right one is the source, if I'm not making a mistake. But the most important part of it is that when you send a signal, again, a threshold voltage that it needs, right? It would make a connection between these two, right? And this big one is also a gate, okay? So if you send it, like, if you connect these to something else, it would also act as a gate, okay? So this is all connected and these are not connected together till you put a voltage here, positive voltage. Any questions?
Sorry, Sina. Could you say that one more time?
Yeah, of course. So the left one, we call it a gate, right? The middle one is your drain and the right one is your source. So if you actually hold your MOSFET the way that the picture is showing, right, you would get that. And then the purpose of the MOSFET is to, when you send a signal, like with some, threshold voltage that it needs, right, it would make a connection between these two guys. Let me put it. Oh, can you guys put it, please? One of the mentors. Thank you. But yeah. So anybody has any question about this? Any question about MOSFETs? What is the one application that you guys think this is going to be useful for? Anybody has any idea? Go ahead.
We can
LEDs.
Hmm? What?
Go ahead, man.
No, go ahead.
Oh, I said you can control the power source supply by applying power to the left leg, so you can use it as a switch depending on if you apply power.
If I have what?
If you apply power to the left leg, then you can open the little gate, I guess.
Right, yeah. One of the really good applications of a MOSFET is that when you want to provide a really high power to a load, let's say like you want to run a motor, right? So let's say if your Raspberry Pi, your microcontroller, right, can only supply 5 volts, right? And up to 200 milliamps, right? But if you want your motor to work really fast and good, right, you want to be able to just have a connection that, connects the power, right? And it will run at the power that you want, but you don't want it to be always on. So one of the applications of the MOSFET is that, right? So you send a signal with your microcontroller, right? And you have one grounding. Let's say, you have the power going here, and then, you have a ground somewhere else, and you put your load in here. So it would go, and then let's say you provide 20 power watt to it, right? So anybody knows what is the limitation for this MOSFET? Like what is the maximum ampere or like the voltage it can handle?
I think some can,
Hmm?
if I'm not mistaken correctly, they could go more than 10 volts, no?
Yeah, more than 10 volts for sure. Yeah.
Yeah.
Yeah. But I think the ones that we have, I was checking, can handle up to 50 volts and like 20 amps.
Oh,
So it's like, yeah, it's like 20 times 50, which is what, 1000 watts, no? So that's a lot of things that it can handle. right? A lot of power they can handle. So that's why they are really useful in a lot of power applications. Any questions?
So do you recommend MOSFETs more for high power stuff?
Yeah, that's what is being used all the time. Yeah.
Oh,
Like, what does it call? If you want to do a DIY project, let's say you want to run your motors, right? It's better that you use MOSFETs for 3 reasons, right? They can handle a lot of power, right? They're really fast at switching, right? So when you send a signal and you send the other signal, it will just turn on and off all the time, right? Then the third one is that they have a lower internal resistance compared to a BJT, right? So one of the things that I actually faced was like for one of our project in the clubs that I was in winter quarter was that we were trying to run a air pump, and my teammates they had a BJT, and I was like, why this is not working the way we wanted because it was really slow, right? And then I was like, we should use a MOSFET, and when we switched from a BJT to a MOSFET, it kind of fixed the problem, right? So they are, I think, the newest and the best thing that you can use unless there's a certain application that you can't use them, right? So, but they're really useful, and like in industry, they're the most used one.
what about transistors? Do they work similar as MOSFETs, or is that different?
Oh, okay. So MOSFETs are basically transistors, right?
Oh, okay.
There are metal oxide, uh, semiconductor field effective something. I don't know, right? Metal oxide, semi, I don't know, something like that, right? But yeah, you can actually send field effective transistors. You know, the FET is basically field effective transistor, and the MOS is metal oxide semiconductor field effective transistors. Yeah, that's their name, right? So they're transistors.
Oh, okay.
Yeah.
But like you said, there's different types of transistors now.
Yeah, you know, we have BJTs, we have IGBTs, we have
Oh, okay.
MOSFETs,
That's
right? And then,
IGBT. Oh, okay. I get it. All right. I get it now.
yeah, and we also have, what is it called, N-channel MOSFET, we have P-channel MOSFET, we have NPN or PNP, right? It can holes and electrons, right? How they're being doped and everything. So yeah, if you guys are into semiconductors, take E2 and E121B. They're the good ones, right? And then yeah, I definitely recommend it. But okay, so how they operate is that we have to send a positive gate to our MOSFET that we have, a positive voltage to the gate that we have to open our MOSFET. But if we want to close it, we need to send a negative voltage. EC2 and EC121B. If you're E, you would have to take EC2, but then 121B is basically one of the upper divisions that out of 8 that you have to take if you want to. I recommend it. But yeah. So in order to power up our MOSFET that we have, right, you need to send a positive voltage to it so you can connect electricity, right? And you can connect voltage and current and everything is going to work, right? But if you want to close it, you have to supply negative voltage, okay? So now we are going to get to the, what is it called? The break rooms, right? Anybody has any questions before we go to break rooms? Okay, that's going to be task 2. How are you going to supply a negative voltage? Okay. So yeah. Any questions that you have before I kind of explain the tasks? Okay. Also, the reason that we got to the task is that I would actually do the circuits and show you guys. So, you're gonna have the answers right away after the break rooms end, okay? So I will give you guys about like 1 hour to do the things. Sounds good? Okay, so the task 1 is that we're gonna use a LED, a MOSFET, a diode, and a resistor and we kind of want to just like, which hand I basically just send a positive voltage and make the LED turn on, okay? Make sure that you have a right circuit. And then one of the things that you can tell is that when you take out your signal that you send to the MOSFET, it would see conduct, okay? So you will see have a complete circuit through the MOSFET, okay? And then I want you to just think about the limitations that we have after sending a signal, right? So what is limiting our circuit, right? I want you guys to use the diode just as a practice. You don't really have to use it, right? Just see how it works. Just put it in the circuit so you get some sort of hands-on with the diodes as well, okay? And then task 2 is gonna take the task 1 and we're gonna see how we can close and open the MOSFET, right? So now you guys be like, oh, I can just do it with a switch, but the purpose is to use a MOSFET, right? So, and us using the switch now is basically our microcontroller later on that's gonna send us like a signal. Sounds good? Okay, so what are we gonna use is one of the capacitors also. Does anybody know why we're gonna use the capacitor here? Anybody know why we're gonna use the capacitor? Right, store voltage, right? So yeah, oh, let me show you guys the capacitor because I don't have the picture. Um, so if you get one of the capacitors in your kit, it has 2 legs, but then one of them is shorter than the other. Can anybody say why is that? Voltages?
Positive side, negative side.
Yeah, exactly, right? So the shorter one is the negative side and right side is the positive side. But does it really matter how we charge a capacitor?
I want to say no.
I think it
I,
matters.
I think it doesn't matter, right? The way that you charge it doesn't matter, right? Because like it would store voltage, but the way it's gonna kind of discharge is gonna be different. I think that's how it happens, and that's how I had my circuit for this to make it work. So hopefully I'm not making a wrong, like what does he call statement, because I'm not sure myself. Okay, but I just want you guys to try it and see how it works. Okay, it's more about the practice than just like knowing it at this time. So what we want to use is that we're gonna use a capacitor, right? And the same circuit that you get from task 1, right? And a switch, right? So when you press the switch and you hold it, your LED needs to be light on. So it's gonna have to have a light, right? But when you press it off, you're gonna see some sort of discharge from a capacitor and your MOSFET is gonna close because of the capacitor has a negative voltage, okay? So when it closes, you're gonna see some sort of a dimming LED also till it kind of completely closes and there's no connection anymore. Any questions about this?
May you explain that again?
Okay, so the way it works is that you're gonna use a switch now and a capacitor, right? Your switch is there to supply your what is it called? Of positive voltage to your MOSFET. So it turns it on, so you're gonna have your LED lighting up, okay? But then when you so in task 1 you're gonna see that you can implement the switch in task 1 too if you want to. But when you press it off in task 1 or you take off your 5 volt, the MOSFET is still on. Okay. So you want to be able to use another device to kind of um prevents that from happening, right? Which is a capacitor, right? And the reason that we use it, there's no other solution basically because we are only allowed to use 1 switch, not 2 switches, okay? So do not use 2 switches, only 1. And just get to it, okay? I think it helped a lot. So I want it to be a little bit challenging too. Any questions? Okay, so I think you should be able to start the let's go break rooms. Let me just stop sharing. Make their break rooms.
I think like the first task that we had to do when building like the circuit with the LED and MOSFET, I think it's just understanding like the difference between the pinout of like the source and the drain and the gate and stuff. And then like I guess like understanding like how it would be dimmer with it, I guess.
Yes or no? Can you guys hear me?
Yes.
Yup.
Okay. Okay, so whoever was explaining, can you explain again? I'm so sorry. I
No, you're,
literally
no, you're good. You're good. I just kind of gave like the vague explanation. I said that it was more like just us trying to figure out like the different pins like in the MOSFET, like the drain, gate, and the source.
right? And then what did we find out about a MOSFET? Anybody else that wants to talk about, or you want to go ahead? What does a MOSFET actually do? Can anybody explain? Please. Somebody explain.
we
Jose, do you
can
want to
use
explain? Okay, go ahead.
we can use the input. We control the input voltage to modify the output voltage. No, the output resistance. So yeah, so it kind of acts like a switch in this case.
Right, it's kind of like a switch, right? And then how does it act as a switch? If you can explain the operation for it. Anybody can explain?
So when you apply voltage to the gate, power will go from the drain to the source. And then when you apply negative voltage by just grounding the gate, it'll turn off the circuit or it'll shut off the drain.
Yep, basically. Okay, I can join. Okay, can you let me in? I should just. Okay, can you guys hear me? I'm sorry. My laptop just got out of the meeting. Okay. So yeah, you're right. So when you supply a positive voltage to your gate, right, it turns on your MOSFET, basically closes the what is it called, the connection between source and drain, and you're gonna start having a closed loop circuit. So you're gonna have a circuit going on, right? And when you supply a negative voltage, right, it would kind of open that circuit, and you're not gonna have any current going through or voltage basically. So you're not gonna have anything working, right? So let me just do let's start making the circuit, right? So how many people were able to figure out task one? Just say yes or no, or you can just, if you didn't, just private message me so I can kind of know. Right. Okay, that's good. But then just in order to kind of explain to everyone how this thing works, right? I would have a smaller circuit here. Oh, that's fine. I'll show. Maybe my explanation was bad enough, everything. So I'm sorry that I couldn't figure it out. But yeah. Okay, so and then let me get some wires here, some wires. Where is the MOSFET that I had? I had the little guy somewhere around here. So somebody that actually made a, do you guys want to show before I make it? Just open your camera. Till I find my MOSFET. Can anybody show? Because I can't find my MOSFET, unfortunately. I
I
don't know
can
where
see
it is.
mine.
I'll appreciate it.
Can't really see much, but
Yeah. So
Oh.
what is happening there,
little button here.
right?
Let's see, I got the negative part of the LED in the middle of the MOSFET, and that's
Right.
has a resistor going to the positive. I have a switch on the other side of the MOSFET that is powered also by the positive. And that one is connected to the gate. So when you press it, the gate opens. And then it is grounded in the, I forget which one it is, the drain in the middle.
Oh, I see. Yeah. So, you should try to see if you can light it up. Like if you give a signal to your MOSFET, right? Your LED should stay on even if you take it off the signal. If that makes sense.
Okay, yeah, I must have done this wrong then.
Yeah, or you might be like giving the negative and positive voltage at the same time to it.
I'll mess
Right.
around a little bit.
Yeah. But thanks for sharing. Anybody has their circuit they can show? Oh, okay, I found my MOSFET. Okay. So can you guys see this guy? Right? I go this little guy here, right? You can see it. So this one should be my gate. This one should be my drain. This one should be my source. Okay. So anywhere that you have your like the fat belly, basically what I call, right? The left of your fat belly is your gate. The middle one is probably your drain, and the right one is your source, right? The way that you wire source and drain to your load can be different, right? But in a good application is that you typically put your load at your source, so there's a little bit more protection compared to when you have it at the drain. Okay, so the idea is that you supply a power to your drain, and when you supply a signal to your gate, these two are gonna get connected. Okay. So anybody has any questions about that?
So the voltage, the 9 volts are going into the source of the MOSFET.
Hmm?
The 9 volts are going into the source. Oh, boy, I'm sorry. 5 volts are
The
going
5 volt,
into
yeah.
the source, right?
Right, yeah.
And then the middle one is acting as it's not the signal, right? It's just draining. It's sending current. Is that what it's
Yeah,
doing?
yeah. So the purpose is basically for a MOSFET is that, you have a high current or a high voltage application, right? But, you don't want to damage your microcontroller, right?
Yeah.
You want to run motors, right? So the way that you do it is in order to control your motors, right? You send a signal to your gate, and then the actual power, let's say you have 7 volt power, right, going through your drain, and it powers the source when it's in the signal, right? But then again, you have to turn it off as well. So you have to supply a negative voltage when you want it to, right? So I'm gonna implement it with one switch for now. Can everybody see how it looks like? So, here's my power supply. The positive rail or the what is it called? The red is basically my positive, and the blue one is the negative, right? So I'm gonna make another wire to my red, and then the negative is just gonna go to the back of my LED here or my resistor, right? Also, we need to always make sure that how we're wiring our circuit. So if I'm giving a positive to my drain, so this is a positive side, so my LED has to be the what is called longer side should be on the source, right? Any questions about that? Okay. So then I'm gonna just add one more wire here to connect my switch. Basically, if I have my switch right, the switch to be here so I can always make sure. Okay. Now I need one more wire to supply my 5 volts. Okay. So can everybody see this? Basically, how it is behaving. So over here, this side that the white wire is going through is my gate, right? And here I have my switch in the same orientation that I told you guys. So when I press it, the 5 volt is going to go through here. It's going to connect these two. It's going to go here. I'm going to supply a signal to my gate, right? And then the middle one is my drain. So I just get a wire, right? And power it off the same rail as my signal, right? Because I want 5 volt to go through, right? But what is happening when I press my button, right? The 5 volt that I'm connecting here is going to connect it to my source, right? So if I kind of show this guy, it's going to get connected to this guy, right? These two little pins on the bottom, right? That are not the gate, drain and the source are going to get connected, right? So what is the behavior we're going to see when I press the button here? We should see. Anybody knows what we should see?
It should be like a dim light, right?
Maybe dim light depends on if your battery doesn't have any more battery, if that makes sense, like it's not that charged anymore. But what we should, anybody else has any idea what it should look like?
Sorry, what was the question again?
So what happens when I press this button? You know, right now, if you see, I have a supply voltage, my LED is off, right? Even though, you know, I'm connecting them through my MOSFET, right? So the source and drain are not connected yet because I haven't pressed the button, right? So what happens when I press the button?
It's gonna light up.
Right, it's gonna light up. It should light up. Let me see. If I have this right. Unless I'm tripping here. Maybe I'm using the wrong LED. Okay, I think I need to debug my circuit too, which is interesting. Okay, yeah. I had my wires wrong for my what is it called. It should be on the side, right? So now I press the button, right? So it start lighting up. So if I take this guy out and put it back, it is still on. How can I turn this off now?
Ground the gate.
What do I do?
Apply a negative voltage to the gate.
Right. So if I go here and it turns off, right? I just put it in a negative, right? So it turns off. So again, so now I turn it off, right? And I press my button, bam, it turns on, right? And if I want to turn it off, I have to physically put it there. Now, anybody has any question about this now?
Why is
So-
this happening?
What do you mean?
Why does it automatically turn off?
Automatically turns off?
Yeah, why it doesn't?
Oh, because like So when you supply, so the way that the semiconductor works, right? So it's like you have a gauge, basically you push it down and it stays there and it starts conducting current for you, right?
Oh, okay,
But
I see, I
then,
see. That makes sense.
right? But it's still there, right? So you need some forces to bring it back up,
So
right?
there's
That's
no
what.
spring or anything to put it back.
No, exactly. It's not a relay, right? In relays, you have a mechanical thing, right? So you need some sort of a what is called electric field all the time going on to hold it, but if it's off, it will go back, right?
Yeah, makes sense. Thanks.
Yeah, but this one is not, there's no mechanical, it's just all semiconductor and all physics, right? So that is the difference. Again, I press it, turns off, turns on, and then I need to go to the negative side to turn it off. Now we need to kind of come up with a solution, right? To let this happen really good. So what is the solution we can use? What do we need to do to don't physically put it back there? So if I press the button and it turns on, and then when I release it, it turns off. What is the solution to it, guys?
Have the gate be shorted when the button isn't pressed.
Right, or you supply the negative when it's not pressed, right?
Yeah, basically.
Right, but then we only have one, we were able to only use one switch, right? So if you had two switches, right, we could just make two switches, one controls a positive and one negative. And then when I press the positive, it would turn it on, and when I press the negative, it would turn it off, right? That was the easiest solution we could do, right? Anybody has any question about that? Any questions? Okay, so now what we do is that we can use a capacitor, one of them. I don't really care which one, right? We put the longer leg, right, onto the negative side, and we put the shorter leg again on the gate, right? So when I press this, it is on, but when I take it off, it should turn off based on my experience. Yeah, you see it start dimming up and it should turn off very later on. Okay, I can show it with a bigger bulb so everyone can see. So I have a really fat bulb here and it should slowly turn off. Right? Is it turned off? Right. Now it's dead, basically. So can anybody explain why this is happening? How the capacitor is doing the job that we wanted to do?
Capacitor store the charge for temporarily, and then when we break when we turn off the switch, it just charge the LED for a while until it runs out.
So your analogy is good, but it doesn't really charge the LED because we're supplying to the gate and gate is not connected. It's not connected to source and drain, right? It's a different concept. It's just a control for them, right? So why are we using a capacitor here instead of just putting a wire? Can somebody explain why we didn't just put a wire here?
The capacitor is meant to store energy, or I'm assuming take the energy away from them. Because the current is
So
still going, right?
yeah, so if you pay attention, right now I just connected the wire, right? So anytime I press the button, it doesn't turn on anymore, right? But when I put a capacitor, it worked, right? So how is the capacitor going to help me? Your analogy is kind of right, Jose, but it needs a trick. There's a trick about the capacitor working there. Anybody knows why?
A capacitor is an open within a DC circuit.
Yeah, exactly, right? So it's going to be open, like, so when we charge it, right, between, like, when we supply from the negative to the positive, it's going to store negative charge, right? So it's going to store negative voltage anyways, right? But when it's charged up fully, it is an open circuit, right? So it can't discharge anymore till we stop supplying the positive voltage on the other side, right? So when it's open circuit, it's not contacting anything, it's not doing any current, right? Open circuit, there's no current, right? So that's why we're gonna see our LED staying up when we use a capacitor, right? And it acts as our like a second automatic switch, basically, right? We can turn it on as much as we want, but when we press it, it would like kind of start dimming out and everything. It should turn down. Oh, I don't have a capacitor here, anyways. So now a second question is that what can we say about the LED dimming? We know that, what is it called? The gate is not connected to our drain and source, right? But we know it is a control to our drain and source. Okay, so when the capacitor discharges, there's no control, like, the light, the LED doesn't dim out because the capacitor is dimming, or what's it called, discharging, right? The discharge is really fast. What can we say about when the LED we see is like dimming really slowly till it actually turns off? What can we say about the MOSFET itself? It's a really important observation about MOSFETs.
It's also storing like some sort of energy from it when it was being supplied.
No, MOSFET kind of stores energy, so there's like some small capacitance between drain and source. Okay. But it's not that big. I don't think it is one of the reasons that it's happening. Or it might be, maybe. Like, seriously. But that is also a good analogy. But there's another thing that I really want you guys to observe. Non-linear charge up discharge? No, kind of right. I mean, I think capacitors are non-linear anyways. It kind of relates to resistance, yeah. But, just as us not being able to explain things, in a physical, like, relationship, what we can tell is that the gate is basically like a kind of, what do we call it? It's like a potentiometer, right? For our drain and source, right? As we supply more voltage to it, it opens up more, so we can have more voltage and current going through drain and source, right? But when it's like closing down, when you're having less supply of voltage into your gate, you have less voltage and current going through, and that's a really important thing about MOSFETs, right? So that's how people can control their MOSFETs also with a potentiometer. Like, it can be a potentiometer, right? You can get a different results when you supply 1 volt to your gate and when you supply 5 volt to your gate. Okay, so if you're working on an application, right? You're doing a motor or something, you're doing a pump, and your pump is not, sometimes working as fast as you want, and you're supplying the right voltage and like wattage to it, it might be your gate voltage that you need to trick a little bit, and maybe you have to open it up a little bit more, right? So this is something that you have to kind of look for when you deal with MOSFETs. Okay. Yeah, anybody has any questions before we go?
Where did you connect the capacitor again? On the longer node on the negative or positive?
Yeah, so in order for us to get a, what is it called, negative voltage through our capacitor, because if our capacitor had two same size legs, right, it would have been kind of impossible for us to do this, right? Because it would just store charge, and it would I think it would always do the positive voltage. I'm not sure. Okay, maybe, I'm not sure. Okay, but then what we know is that the shorter one is a negative and the longer one is a positive, right? In order to get a, if we had a positive side on the positive rail and then just put it back into the circuit, right? It would just have a positive voltage into it, right? But then if you do, because if I do it this way, also, I want to show, it would never discharge, I think. That's what I saw for the last time. Let me see if it's going to do it. Yeah, I would stay on because, like, this is not going to have a negative charge, right? This is not going to discharge a negative charge. This is a positive charge. And it's not doing anything. It's just getting, there's nothing going on here at the gate when I press the button, right? But when I press the button, I think I can have a little bit dimmable more. But anyways, so yeah, if I just do this, it turns off, right? So the positive goes to the negative and it starts charging negative charges, right? And the negative one is going to discharge the negative. Okay. So this is going to slowly discharge now. Okay.
So every time I press it, it gives it uh voltage and then it dissipates.
Yeah, it dissipates a negative voltage to our gate. So it slowly closes our gate,
Okay.
right? Also, again, what was her name? Kayleen kind of mentioned that there's gonna be some capacitance between drain and source, which is the correct thing. So that's why we also have a smaller discharge and kind of like a dimmable light we see.
Mhm.
Yeah. Okay. Any other questions you guys might have about MOSFETs? All good? No more questions, guys? So let me just find a feedback survey and just you guys put that too. And then we can go home, I think.